Hello guys, welcome back to this video. It's a continuation of heat and thermodynamics. So we're going to be solving for area expansivity and cubic expansivity. So let's get started in this video. But don't forget what I told you. Whenever you're trying to solve a physics question, list out the parameters given, convert them if necessary, and apply the formula to get your result. So in all my videos, what I'm just actually teaching you is how to solve physics related questions and get good grades in your academics, in your colleges, in whatsoever exam you're going to take. So let's get started. So number 2, they said the linear expansivity of the material surface of a metal is 12 multiplied by 10 to the minus 6 Kelvin inverse. If the area of the metal through 50 degrees Celsius is 100 centimeters squared, find the initial surface area of the metal. So we're going to list out the parameters. So let's say EG2. So we have the parameters as the linear expansivity. We have it as 12 multiplied by 10 to the minus 6 Kelvin inverse. We said if the area of the metal through, so this is the change in temperature, that's 50 degrees Celsius. And we said the A2 is 100 centimeters squared. And also we should find A1. So don't forget the formula for the area expansivity. B is equal to what? A2 minus A1 over 2A1 change in what? Theta. I believe you haven't forgotten this. Remember B is equal to what? 2 alpha. Do we understand this? So let's kind of get started. So I'm looking for A1. Let's kind of make A1 the simple formula here. So this is what we're going to do. So let's continue from here. So we have B over 1, A2 minus A1 over 2A1 change in theta. Change in theta. So we're going to cross multiply. So we have something like this. 2A1B beta is equal to what? A2, sorry. 2A1 beta change in theta is equal to what? A2 minus A1. So we're going to bring this to this side. So we have 2A1 beta change in theta plus A1 is equal to what? A2. So we're going to bring out the common term here, that's A1. We have A1 open bracket 2 beta change in theta plus 1 for A2. Then the value start like this. 2 beta change in theta plus 1 change. So this is change, not A. Change in theta plus 1. So this cancels this. So we have general formula for A1 as A2 2 beta change in theta plus 1. So you can jot this down so that whenever I see this kind of question, you just impute it without having to stress to solve. So let's kind of continue. So we've given us A2. A2 is this. So we have something like A1 is equal to what? 100 centimeters squared over 2 multiplied by the beta. Is it beta? Yeah. So the beta will be this. Do you understand? This will become the what? The beta. I'll pay attention. No. This is same. Okay. So this is no longer beta. It has become alpha. Do we understand? Since we have introduced the 2, the beta has become alpha. So instead of writing beta here, we're just going to replace it with what? Alpha. So 2 beta, like this is what we're saying. How should I put it now? Okay, yeah. So let's replace this with alpha. So this will be alpha. Do you understand? So this is what I'm saying. We have this as this as this. Do you understand? So beta. Okay, this is the formula for the transformation when beta has become to alpha. So this will be what? Alpha. Do we understand this? So in other places to see beta, you can replace it with what? Alpha. Do we understand? So let's just get started. So don't forget all this as a general formula. Do you understand? So we have 2 multiplied by alpha, that's 12 multiplied by 10 to the power of what? Minus 6 multiplied by change in theta, that's what? 50 degrees Celsius plus 1. Do we understand that? So we have A1 is going to be 100 centimeters squared over. So 2 multiplied by 12, that's 24. 24 multiplied by 50, let's check that. 24 multiplied by 5, that's 0. 2, 5 times 2, 10. 120. So 1 to 200 divided by 10 to the power of 6. So 2, so this will be 12. This will become 4. So that's 12 over 1, 2, 3, 4, and that's 0.0012. I hope paying attention. So plus 1. Plus 1 is going to be 1.0012. So when you just take a calculator, input everything, you get something like this. We have 1.0012. Yes, 1.0012. Do we understand it? So let's kind of divide it. So when you kind of divide your answer, you're gonna have something like this. Okay, when you kind of divide it, so should we divide it? So let's kind of divide it together. So we have something like 100 divided by 1, 2, 3, 1, 2 over 1, 2, 3, 4. So so we have something like this. 100 divided by 10012 times to the power 4. That's 100 times 10 to the power 4 over 10012. Then you multiply that times to the power 6 over what? 1, 2, something like that. So let's kind of divide this 1012 in 1 million. So to have this in 1 million, we should have I suggest we should have something like this. We have 10012 multiplied by 10. Let's check. It will be 100120 123. So it's not yet that. So yes, 10. Okay. So let's kind of make it 100. So we have 1 0 0 1 2 1 2 2 3. So this is more. If we make it 100, it will be more. Do we understand that? So let's use 9. Let's use 99. So 10012 multiplied by 99, and let's see what we have. So we have 8, 9 to 2, so it means 1, 9 times 1, 9, so this is 10, 0, this is 1. Okay, that's 18, yeah, 10, yeah, 0, that's 1, 0, 9, so just repeat the same thing, 108. So when we add everything together, we have 8, 8, 1, 1, 9, 9. 1, 2, 3. So we have something very, very, very close. So we can have 99. So when we minus this from 1 million, what should we have? 1 million minus this, that's 8, 8, 1, 1, 9, 9. So when we minus this, so we'll go this one 9, 9, 9, 9, 9. This is 10. This is 2, this is 1, this is 8, this is what? 8. So we have something like this. So it will mean so when you minus it, you understand, it will mean 8,812. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So we have the decimal point and answer. So how many of this we're gonna see in this? So we should have something like 8. Do you understand? 8, approximately 8, 1012 multiplied by 8, that's 16. 8, that's 9, 0, 0, 8. Is it close? So it should be should we say 9? We can't have 9. So we should have something like 82, 83, 84. So let's just have approximate value of 8. So what I actually do here, we just actually did it manually to get the answer. So we have an approximate answer of this. So we have like 99.8 centimeters squared. So if you kind of do it, do we understand this? I believe you understand. So I want us to solve for cubic expansivity. So just spare me a minute, please. Thank you. Okay, yeah, thank you. I just kind of went for a quick break. So we're going to start for cubic expansivity now. You understand? That's the gamma version of it. So it said linear expressivity of the material of a cube is 12 times 10 to the power minus 6 Kelvin inverse. If the length of each side of the cube is 10 centimeter, find the area of one face of the cube and the volume of the cube when its temperature is raised by 30 K. So in physics, whenever you're trying to solve it, list out the parameters given, cover them if necessary, then apply the formulas. Do you understand? So we are reminded, let's say PG3 solution. Solution. Is it solution or solution? So we have the gamma, do you understand, as 3 alpha. So we're going to have the alpha as V2 minus V1 over V1, 3V1 change in what? Theta. Let me write my theta very well. So this is the formula whenever you're solving cubic expansivity. Do you understand that? So the first and foremost is that the cube, give us a cube. This is the cube. So I want you to know that the cube has all lengths equal. Do you understand? Something like that. So the second side of the cube is 10. Say this is 10, this is what? 10 centimeter, and this is what else again? This is what? 10 centimeter. Do you understand? So then I said we should find the area of one face of the cube. So the area of the cube, I guess the area of the cube should be 6x squared. Am I correct? So we have 1, 2, 3, 4, 5, 6. 6x squared. I believe something like that. So we have something like 6 multiplied by what? 10 times what? 10. That's 600 centimeter squared. Do we understand that? So now we are not that this is the question, this is part of the question, so we should find this. So the next thing we're going to do, we're going to find for the volume of the cube. That's the volume of the cube. V is given as S cube. So since S is what? 10 centimeter, so V is 10 cube, and that's what? 1000 centi what? Cube. I believe you understand this. So now here's what I want you to do. It said, okay, it said, and the volume of the cube when its temperature is raised by 30 K. So in this kind of question, they are asking us to find for the second volume, that's V2. So we have V2 here. So let's make V2 the subject formula here. V1 is already this. Do we understand this? So making V2 the subject formula, so we have something like alpha multiplied by 3V1 change in theta is equal to what? V2 minus V1. So bring this here. So we have alpha. Let me say 3 alpha V1 change in theta plus what? V1 is going to what? V2. So we have V2 as this. So let's just kind of bring V1 out to kind of make it simpler. So we have V1 plus 3 alpha change in what? Theta plus 1 to what? V2. So what is V1? V1 is this. What is alpha? Alpha. Okay, they've given us alpha. Alpha is 12 multiplied by 10 to the power minus 6 Kelvin inverse. Okay. What else again? And they give us the change in temperature as 30 Kelvin. Do you understand? So let us have everything and input it here and let's see what we get. So V1 is 1000. Do you understand? 3 multiplied by this 12 times 10 to the power minus 6. Okay, this is multiplication. Okay, times what? 30 Kelvin. I'll pay attention. Plus 1. So when you bracket this one with the little bracket, everything, so V2. So when you kind of multiply everything together, that's what we got. So 3 multiplied by 12, that's 36. 36 multiplied by 30. 36 times 30. Well, let me see, 36 times 3. 36 times 3, that's 8. That's 108. It just has 0. So 108, see, divided by 10 to the power of 6. So you have this one with 5. When 10 disappears, so you have 0 0.12108. Do you understand? So when you add 1 to it, 108. Do you understand this? So we have added everything together. So this is what we got. So we have 1000 multiplied by 1.10108. Do we understand this? Centi cube to what? V2. So when you kind of multiply it, so 1000 multiplied by 1000, so it's going to be something like this. More simplified. 1, 2, 3, 4, 5. So you have 1, 2, 108 over 10 to the power of 5 multiplied by 1000 is equal to what? V2. So this will be 5 zeros, you understand? So this is what I'm saying. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3. What remains? 2 zeros, you understand? So this divided will be 10108 divided by 100. So you have 1001.08 centicube. So for that, we'll come to the end of this video on that heat and thermodynamics. We understand. Then we can move forward into the next video. See you there, organize it.